This right here is talking about the vertical line test. And this is something that you've done before. And I just feel like that this right here really helps explain the vertical line test. Some people call it maybe the pencil test, and they drag their pencil across the graph. And so we have a graph right here, and there's going to be a blue line that comes across this graph. Now, what we're looking for is, does this blue line ever cross the red line twice at the same time? And it's always kind of confusing until we get down to the bottom row. And so let's just watch and see what happens. So watch this blue line. So it's going to move across. And the entire time that that line moved across, it was only touching the red line once the entire time. And I know a lot of kids are like, oh my gosh, I don't understand what you're saying. Just stick with me for a second. So let's take a look at this. So that is a function because the entire time it only touched it once. Now, if it ever touches it twice or more than once, then it's not a function. So let's see this one. So here comes our line. So there it is. Whoop. And it went quickly. So the entire time that it moved across it, if I was to pause it, it would only be touching the red line once. And then if I started it again and paused it again in a new spot, it would still only be touching it once. So it might be in a different spot, but it never touches that red line twice at the same time. Okay, I always hate the fact, so that is a function right there. I always hate this next one. You need to see this one, but I just don't think it should be the first one we see that's not a function. So this blue line is going to come through and boom, it touches it everywhere. And so remember, it's only allowed to touch it once, and yet this goes right on top of it, so it's touching it absolutely everywhere on that line. So that's not a function, but once again, it's probably not all that clear. So let's take a look at this one. All right, so watch this blue line. All right, so I never saw where it was touching the red line twice at the same time. And once again, I know you're probably a little bit, not sure, but I think this will start to make sense on this one. And so look at this one. All right, so I want you to imagine this blue line coming across this right here. And so this blue line comes across and boom, how many times is it touching that red line? Twice. Once on top and once on bottom. This is not a function. And so we're always looking for this imaginary blue line that's going across every single one of these graphs. And if you can ever stop that line and it's touching it twice, then it's not a function. Okay? So then we have this one. And so unfortunately on this one, there is no blue line. I don't know what happened to the blue line, but the blue line doesn't exist. So I'm going to try to draw a blue line here. So imagine we got a blue line that's coming, and I'm just going to start real simple right here. So we just draw this blue line right there, and it's only touching once right here, okay? So I'm going to get rid of that line. Well, let's see if I went right here. Yeah, it's only touching once. I always get some kids that go, well, what if we went really, 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 and you're sitting there going, well, maybe it's touching it. It had better be obvious, okay? And so if you're looking at it and you're not sure, then it's probably a function. So it'll be very, very obvious if it's ever not a function. So like it's clearly straight up and down. This still looks like it's bending a little bit. And so there's nowhere where I could draw a vertical line where it would cross it twice the way we did right here, where we just drew this and it definitely crossed twice. And so that is a function. All right, so I think this next one has, maybe, is it going? There we go. All right, so right here, here's our line. So our blue line went across. Right here, it crossed it twice. So that is not a function. And you'll get to where you can just see it. I mean, clearly, if I draw a vertical line on that, then that is not going to be a function. So right there and right there, that is not a function. All right, so I'm kind of hoping that that makes a little bit of sense. And then, so right here, We just want to know if it's a function or not, so you only look at the x's. So all these have one arrow. I don't care about this one. Quit looking. I know you were looking at it. We don't care about that. Just these right here all have one arrow. This is a function. Okay, down here, we look at the x's only. The x's repeat. They're not allowed to repeat, so this is not a function. Okay, up here. So if I draw this vertical line, so first off, if I draw right here, oh, it looks like a function. But the question is can you draw it anywhere? And so just because you can draw it where it only touches once, that's not the question. If I draw this line, it touches it 1, 2, 3 times. It only has to touch it more than once. So as soon as it touched it twice, it was not a function. So clear that. All right, so this is not a function. And then this last one, as we look at it, so remember, we're only looking here. And I look at this 2, and it's got 2 arrows, so that's not a function. All right. So now we're going to move into something called function notation. We've, I think, talked a little bit about this, but I haven't really gone into too much depth. So we're going to start talking about this f of x and g of x. And what I need you to know is that f of x and g of x is the same thing as y equals. So here's the big question. Why in the world would we ever want f of x and g of x if y equals does the exact same thing? Why not just always use y equals? Well, right here is exactly why. Because in this, they are giving us 2 separate things that we're looking at. So they want to know what the answer is when we plug 3 in for the function that has the f and the function that has the g. Well, because of the fact that it's got the f and the g, I know exactly which functions they're talking about. If we didn't have the f and the g, and it just said y equals and x is 3, I wouldn't know which one they're talking about. And so this right here allows us to name the functions. And so I know it's maybe not the best name in the world, but f is the name of this function, and g is the name of this function right here. All right, with that being said, what we're about to do is going to be extremely easy if you know how to use the Desmos calculator. So we're going to go and click on the Desmos, so Desmos, and then calculator, so right there. And we want the graphing calculator. So earlier this week, I told y'all that we would be plugging in and using table. Well, here's where we're going to use table. So first off, when we look at this, this is saying that, sorry, I'm trying to get my pen. So whenever we look at this right here is just like my y. And of course, this is my x. So when we come down here, notice that this number right here took the place of x. So instead of saying x equals 3, if they say f of 3, that's telling me that x is equal to 3, because look, it just took the place of x. And so now we can plug 3 in for x and work this out and figure out what the problem is. So if I go 3 squared plus 3, 3 squared would be 9, plus 3 is equal to 12. Well, but then I got to work it out again for -2, and I got to work it out for 2. So we don't want to do that. We want to use the calculator. So when we see that we have our function here, f of x, in the Desmos, then we are going to put a y, okay? And I'm going to work out everything with an f first, and then we'll do a brand new graph with the g's. So I'm going to go to our calculator. Matter of fact, I'm going to do this right here. Y equals x squared plus 3 to help me out, because I'm an old man and I forget. So we got y equals x, and then remember to get the squared, you got to click this, squared, there you go, and then you can get rid of it. All right, and then plus 3, so plus, oh, got to make sure your mouse is back in there, plus 3. All right, so if you remember, we decided that we would not hit enter We're just going to leave this here, and then we'll hit the gear, and then it brings up table. Now, 3 isn't here. So what am I going to do? You're going to go to the bottom, move your mouse down to the bottom right here, and then you can type in the X, 3. And remember what we got? 12. Well, this just did it for us. And then we can go down 1, and I think the next one was -2, which is 7. And then I think, oh, no, not 22, 7. And then go down 1, and then 2, which is also 7. And so we can just sit there and type these in now, and it's going to give us all of our answers. So right here, we had 12 is 3, -7. Which one was it? This one. All right, so right here, we've got, so on number 9, you'll write f of 3 equals 12. And then f of -2 equals 7. And f of 2 is also 7. Now, I don't know if you caught it, but whenever we looked at it in the table, this right here also makes the point 312. Now, we really don't refer to it like this. I just want you to see that this is all making points. So if you see that relationship, then you kind of understand that what's inside the parentheses is the X, and that this is our Y right here. Okay, and that's what we're trying to get you to see. All right, so now I can go plug in this G of X, but G of X is a totally different equation, X plus 1. So I'm going to come back over here. I'm going to reload everything, because anytime that we do something new, we reload it. And then we're going to do X plus 1. So X plus 1. Oh, I forgot to do Y equals. Now notice, even without the Y equals, it actually still graphed it. But I'm going to put Y equals. All right, and then we're going to go do the table. All right, and so now I need to know what my numbers were. I wasn't paying attention. So 3, 0, and -1. Now, actually, we already got 0 and -1. So we just need 3. So we're going to go down here, type in 3. So 3 is 4, 0 is 1, and -1 is 0. So we got 3 was 4, 0 was 1, and -1 was 0. Okay? All right, so today you're just going to be going through and you're plugging this into the calculator, and then when you see this right here, and inside of the parentheses where the X is, there's a number that's saying X equals 5. So type it into the Desmos, turn it to a table, put 5 in, and you'll have your answer. I do want to show you this kind of special one right here. I meant to kind of update this, but I failed. So right here, here's our equation. So you're going to go type this into the Desmos. Now, domain is something we have not talked about, okay? So we actually talk about it next week, so I'm a week ahead. So domain is your X's. So what they're saying is, same way here that 3 would be an X, I actually have 4 X's. 1, 2, 3, 4 X's, and we want you to find the Y's. So if I have 4 X's, how many Y's am I going to have? Well, I'm going to have 4 Y's. So I expect 1, 2, 3. Oh, that was supposed to be a space right there. 3, 4 answers to this. And so you'll plug this into table, and then you'll probably have 0 and 2, and you'll have to type in 4 and 6 to get all your answers. And then we got, remember, you can type this one into Desmos because it's got all the same letter, but we have to use X. And then this one you have to work out, and we want to see if you're getting any better at these. Remember, we want to subtract the X first. So you'll subtract 5X to both sides, and then we divide by the number in front of Y to everything. So see if we can do that. All right, good luck.